Okay, hi everybody. So what is the implicitization problem? Well, given a map, let's say a map from R, just to be concrete, R2 to R3, whose component functions, functions, this is my abbreviation for functions, are polynomials. In fact, or rational functions. That means a ratio of polynomial divided by another polynomial. Like 1 minus t squared over 1 plus t squared is a rational function. This is a rational function, etc. The image of the map is contained in an algebraic variety in R3. Okay, and why did I do R? Well, I don't know, because that's what we usually picture, but this works for any field. Okay, some things don't work for any field, like some things only work for C. This worked for any field, in K3, whose equation we would like to know, whose equations we would like to discover. And really, these are called implicit equations, and this is called a parametric map, or sometimes parametric equations. Okay, so what is the implicitization problem? Find the implicit equations defining the image of F. Well, it's a risky closure of it, but let's just ignore that for now. Okay. Now, how do Grosvenor bases solve it? So, how do Grosvenor bases solve it? Well, if you decided to call these variables x1 and x2, and if you decided to call these variables y1, y2, y3, then you would create an ideal. Create I equals, okay, so y1 minus the first component function, y2 minus the second component function, y3 minus the third component function. And this is an ideal where? It's an ideal in this ring. x1, x2, y1, y2, y3. So it is in, it's really, this is the ideal defining the graph of this map. Create I in this bigger ring, and then compute a lexicographic Grosvenor basis for I with the order. Well, okay, so what we want to do is we want an equation in just the y's. So that equation in the y's will cut out our surface. Like perhaps our surface is defined by this equation. Okay, well, now it's an equation. It's defined by this polynomial. So you see, there's no x's there. This is what we want. This is the implicit equation of a sphere. And so what do? Well, we make the x's very expensive. And then the y's, well, we really don't care what order they are, but they should come after the x's. Now, grab whatever Grosvenor basis generators only have the yi variables. Grab them. They are the answer. That's it. They're the implicit equations. So I encourage you to try this out. Discover this equation by using the map that says y1 is equal to, and I say, y1 minus, and now, what is it? Okay, so what was our sphere parameterization? It was 2x1 over 1 plus x1 squared plus x2 squared. And then it was, oh, that's good. And then think about this equals 0. And then the next equation would be y2 2x2 over 1 plus x1 squared plus x2 squared equals 0. And then another equation. So we didn't pretend we don't know this one. We want to discover that. So we take this, and the last equation is our last component function, 1 minus x1 squared minus x2 squared over 1 plus x1 squared plus x2 squared equals 0. And now I would like to say generate the ideal by these three polynomials, but they aren't polynomials yet. So the best trick is the trick called clear denominators. You'd be amazed how often the solution to some problem is to clear denominators, even in advanced math. So if I clear denominators here, what do I get? Well, 0 times whatever is still 0, and then I have a 1 plus x1 squared plus x2 squared times y1. And now look, this is a polynomial equation. Same thing here. So I just clear denominators, and I get a polynomial equation. And I clear denominators, and I get a polynomial equation. And now we can generate the ideal, compute a Grosvenor basis with respect to this order. And that Grosvenor basis will have exactly one element in this case because there's only one defining equation. And that one element that has no x's in it will be this implicit equation. So we could discover this equation. Okay. And it should be clear this doesn't just work for 2 input variables and 3 output variables. It works for any number and for any rational function because you just clear denominators.